Alright, welcome to the day 1.5 lesson video over the distance formula. So we're going to talk about this. There's a formula that we use, an equation we can always plug into to find the distance between 2 points on the coordinate plane. A distance would be the length of a segment with these two endpoints. So if I put a segment on the coordinate plane, not just a number line, not just out in space, but if I put a segment on the coordinate plane and we assign values to those points, we can find the distance between those, which would also be the length of that segment. So here's your formula for distance, and this is extremely important. Make sure that you have it copied down. The distance between any 2 points on the coordinate plane starts off with this big square root part of the equation. So a big long square root. The first part of the square root, we do parentheses. We want to take the difference of the x coordinates. So I'm going to do x2 minus x1. That order doesn't really matter, but I like to start with the second one first. Okay, we're going to find the difference between those 2 points by subtracting, and we're going to square that. But then we're also going to add the difference between the y values squared. So if I did x2 minus x1, I have to do y2 minus y1. Make sure our square root extends above all that. So we're going to work through some problems, but this is the formula you need to know. It will be on the test. You'll need to know it. We will use it probably in just about every unit we have from here on out. So the first thing we're going to do is talk about using the distance formula when they give you the graph. Now, I will tell you in class a little bit more about this, but the distance formula really just comes from the Pythagorean theorem. And I'll show you how that works out on the graph. But all we're doing is taking the horizontal distance, that's the x distance, and squaring it, and the vertical distance and squaring it. But we can use these 2 points and the distance formula to find how far they are apart. And we can't just count spaces unless it's a horizontal segment or a vertical segment. So the first set of ordered pairs, x1 and y1, we're just going to pick one of the points to use. I'm going to use this one on the far left. That would be the point -5, 3. This is the negative side of the x-axis. The x-coordinate is the horizontal distance from 0. So that is -5. And then the vertical distance from 0 on the y-axis, or in the y direction, is 3. So that's our first point right there. And this other point, in this, we would call this the third quadrant. Remember, quadrants are starting here, 1, 2, 3, and 4. So over here, this point has the ordered pair -2, -3. And we will review how to write ordered pairs in class a little bit. But those are the ordered pairs I'm going to use. And so I'm going to plug those into this formula. So the distance between these 2 points can be found like this. We're going to take the second x-coordinate. x2 just means the second x-coordinate. So the second x-coordinate is -2. And we're going to subtract the first x-coordinate. Since the first x-coordinate is a -5, this minus that negative, we turn into a +5. Okay? And over here I'll make this note of how I got that. -2 minus -5 is really equal to -2 plus 5. Okay? We don't write a double negative like that. We change it to plus positive. Then we're going to square that result. Then we're going to find the difference of the y values. Okay? The y value, the second y value is -3. Then we subtract the first y value, which is 3. I leave it as a minus this time because that was actually a positive there. Okay? -3 minus that +3. We'll square that. And then we start to simplify this. Even if you have a calculator that could do all this at once, I want you to simplify it on your notes, following along, showing your work. We're going to write -2 plus 5. Instead of that, we're going to go ahead and do that math. -2 plus 5 is +3, so that's a +3 squared. And then -3 minus 3 is -6, so that's a -6 squared. You need to write it this way because I really want you to make sure you don't end up getting the wrong number here. When we square a negative number, it always changes into a positive. Okay, so the first one, +3 squared, you already know is probably 9, or you probably know it is 9. Okay, But when I square negative 6, it's not negative 36. Remember, squaring it means multiply by itself. So I would do negative 6 times negative 6 and get a positive 36. Okay? And so now I can add those two together. 9 plus 36 is 45. So our answer is actually going to be rounded in this case because 45 is not a perfect square. I'm going to explain that more in class. And so we would put that into the calculator and round our answer, and let's use 2 decimals to round. And so the square root of 45 is about 6.71. Okay, it's actually 6.708, but that number after the 0 is bigger than 5, so we round it up to a 1. And that is the answer for the distance between those 2 points. Okay, I want you guys to try and do number 2 on your own. Okay, when it says find AB, given that A has these coordinates and B has these coordinates, remember AB is just the length. Okay, so AB, written that way, wants the distance between A and B here. So we're using our distance formula again. So we're going to start out this way. This is x1, this is y1, this is x2, this is y2. I want you guys to try and do the distance formula on your own like we did. If you do get stuck, you can push play and watch how I do this. But I want you to try it on your own first and see if you get the right answer. Okay, that should be enough time. If you need more time, pause. But this is what you should get. Okay? If I plug in my x1 and y1 here, you do get 3 plus 4. I'm sorry, x1 and x2. But 3 plus 4, because 3 minus negative 4 is 3 plus 4. And then negative 1 minus 1 gives you a negative 2 here. So I have 7 squared plus negative 2 squared, which would be 49 plus 4, which is the square root of 53 here, which is about 7.28. Again, if you have any questions over any of these, or if I'm going too fast in the video and you still don't understand it after rewatching it, come into class and ask me those questions, and we'll have time to discuss it, and you'll learn a lot more from asking those questions. Okay, we're going to skip over number 3. If you want to try this one on your own, just for the extra practice, you're welcome to. Otherwise, we will do that in class. Okay? But we're going to look at an application part of this, and I'm going to help you get it set up, and then I'm going to have you do this on your own. So let's pretend this was a map showing you a location of the post office and the high school. Okay, and I've put these on a graph for you this time. Okay, so we've got some map location where these are the 2 locations, and I actually give you those coordinates for each one, and it's asking you how far is it going to take to walk directly to the post office from the high school. If we could walk directly from the high school to the post office like that, how far would that be to walk? And so we're going to apply that distance formula. Okay, PH, if you want to assign a segment length value to it, or you could just say the distance equals. So I want you to plug in these coordinates, x1, y1, x2, y2, to your distance formula and find how far that is. Okay, I'm actually going to not show you what your answer is yet. I want you to bring this to class completed with your answer, and I'm going to let you compare with a partner in class and see if you can do this or see if you've got the right answer doing this on your own. Okay, now we're on the back of this notes page. We can actually apply the distance formula again when we talk about the perimeter of 2-dimensional shapes. And so I'm going to give us some examples of 2-dimensional shapes. The first one will be a triangle. The other ones will have 4 sides each. But remember that perimeter is always just the sum of all sides. So we're going to find the side length separately using our distance formula here. Sorry if you couldn't read that. Now you can. Sum of all the sides is our perimeter. We're going to find all of our side lengths, and then we are going to add them at the bottom like that to get our answer. We'll write it in back here. I've zoomed in so you can see this, so I'm going to have to move the page back and forth so you can see what I'm writing. Let's try the first one. The first thing we always want to do is to graph the points and then find the perimeter of each shape using that distance formula. So first of all, we're going to graph these points. Number 1, 0, 1. That 0 for the x-coordinate tells you stay on the y-axis, and then you go up 1 unit for y. And then 2, 1, we go over 2 and then up 1. And then 2, 4, we're going to go over 2 and then up 4. And so we get this triangle when I connect those dots. And so we want to find those 3 side lengths. Now, I'm going to give you a helpful hint here and allow you to take a shortcut. Any horizontal segment like this that goes left and right, it doesn't go diagonal at all, it just goes left and right, you can count the units because the y values don't change. And so whenever we do this, there are no y values to really consider because they don't change. So the only change we're making is horizontally, and so we can just count the length. So side 1 here goes from 0 to 2. We know that is a length of 2. So if I call this side 1, that is a length of 2. Then side 2, I'm going to use the vertical side, the same idea. The x's don't change, and so I can just count what side 2 is, and that is a length of 3. We go from 1 up to 4. Okay, if you're doing this by subtraction, this would be like 0 minus 2, or 2 minus 0. Distance can never be negative, so that's why I write it that way, and I get that answer. Same thing here, that would be 4 minus 1. Which in this case is 3. So side 2 has a length of 3. And then side 3 is diagonal. We do have to use our distance formula there. So we're going to use these coordinates for side 3. Okay, we're going to use 0, 1, and 2, 4. So I will write those for you here. Okay. So we're going to actually use our distance formula to calculate that. Okay, the x's are 2 and 0, so I'm going to do 2 minus 0 squared. And then the y's in corresponding order are 4 minus 1. 2 minus 0 is 2. 4 minus 1 is 3. 2 squared is 4. 3 squared is 9. So this is the square root of 13. And then I will need to round that to approximately 3.6 or 3.61. I've been doing 2 decimals on all the rest, so I'll do that. So one of our sides is 3.61. The other 2 sides are 2 and 3. And so all I have to do is add those together and I get my perimeter. Okay, so 2 plus 3 is 5. And then 5 plus 3.61 is 8.61. So the perimeter of this triangle is about 8.61 units. Okay, so we found the separate sides, and we added our results. Okay, we're going to get started on this next one, and I'll get you started and then let you finish it. So we first want to plot these points, -4, -3. 0, -3, -1, -1, and -3, -1. And so this would be a trapezoid. We have 2 parallel sides here. Okay, those are sides, I'm just going to call them 1 and 3. This would be side 2, this is side 4. So side 1 we can easily count because it's horizontal. That is a distance of 2 units. Okay. -3 back to -1 is a distance of 2. Okay, and then I'm going to skip side 2 for a second. Side 3 was this other side right here, and that's a distance of 1, 2, 3, 4 units. So I know those 2. But for these 2 diagonals, you're going to have to use the distance formula. For side 2, you're going to use the first point and this last point. Sorry, that's side 4. I'll flip these around. Okay. Use your distance formula there. And on side 4, you're going to use the other 2. Sorry, that's side 2 now. I flipped those. Okay, and the video won't allow us to show the rest of this, so we'll do the rest in class.